talking a lot about segments. Okay? So a segment is a part of a line. All right? A segment is a part of a line. The difference between a line and a segment is a segment has endpoints on both sides. So segments are a finite length. They don't extend forever. Lines extend forever and do not have a measurement. Okay? Segments do have a length. Okay? They stop at two endpoints. So the distance between 2 points A and B can be written two different ways, and this will be where our symbol sheet will come in a second. We can call the distance between 2 points as the length of the segment. Between A and B would be A, B. Or the length could just be written two letters together. So if you're talking about the length of a segment, then it's just the two letters written together. I'm looking for my marker. So on our symbol sheet, you just see two capital letters written beside each other with no symbol. That means the length of the line segment. Okay? Sorry, I didn't have a room to go across like y'all do. So just two letters written beside each other means the length of that segment. Y'all, that is important. Please make sure you write that down on your symbol sheet. Okay? Our symbols are very important. If I write it on this board over here for symbols, you need to make sure you're sitting on the sheet. So we should have like maybe 4 or 5 things on that sheet now, right? Right? Okay. All right. So if you just see the two letters, it's talking about the length of a segment. Okay? Something else we need to if we're talking about the length, it's just the two letters together. Go ahead and add this to your symbol sheet. If you have a straight bar with no arrows, then you're talking about the segment itself. Okay, so if there's no symbol, just two letters together, it's talking about the length of that segment, like the measure of it, 5 centimeters or 10 miles or whatever. But if it has the bar over it with no arrows, that's talking about the actual segment. Okay? Okay? It's important to know the difference because this is just the name of the segment. This is actually the length of the segment. Okay? All right. So, over here, it has a picture of a segment on a number line, doesn't it? Y'all see that on your paper? You can probably see it better on your paper than my screen. This endpoint A is at -1, correct? And B is at what? 3. How many units are between -1 and +3? 4. So AB together is asking for the length of segment AB. It would be 4 units. It didn't say if those are centimeters or what, so it's 4 units. Okay? All right. Congruent segments. All right, here's another symbol we need to add to our sheet that we're going to see lots and lots and lots. A squiggle on top of an equal sign means congruent. Congruent. A squiggle on top of an equal sign means congruent. Okay? So if we're talking about segments themselves and if they have equal measures, then we can call those segments congruent to each other. So if the length of AB equals the length of CD, if their measures are equal, then we can say that the segment AB is congruent to the segment CD. So measures get set equal to each other. So this is talking about the lengths of both the segments. Measures are equal. The objects themselves are congruent. Okay? We don't say segments equal each other. We say segments are congruent to each other. And we don't say their length is congruent to each other. We say lengths are equal. Y'all see the difference? Lengths are equal, segments are congruent. All right. The next thing we're going to talk about is one of our very first rules in geometry. It is our very first rule in geometry. And it's called the segment addition postulate. The segment addition postulate. So I'm going to use this little picture over to the right as our example. How many segments are in this picture? How many different line segments are in this picture? There's 3, right? You have segment AB, you have segment BC. So here's AB, here's BC, and then the whole thing is AC, right? Right? Y'all see the difference? Okay. So the segment addition postulate basically says if I have a point that's between 2 other points, then the 2 smaller segments add together to equal the length of the larger segment. So basically, the length of AB plus the length of BC equals the entire length of segment AC. So I like to call this little plus little equals big. This little segment plus this little segment equals the big segment. Okay? The 2 little segments added together equals the length of the big segment. Little plus little equals big. Okay? Now, these 2 segments do not have to be congruent. Sometimes they are. If B is the midpoint or the center of that line, the 2 segments would be congruent, but they don't have to be. These are not. This does not look like it's congruent, does it? It looks like AB is smaller than BC, right? Okay? So sometimes they'll be congruent segments, and sometimes they will be different lengths. All right? But segment addition segment says the 2 smaller segments add together to equal the length of the larger segment. All right? Little plus little equals big. All right, let's do some examples. The next one says we're going to use this same diagram to answer questions 1 and 2. So we have this diagram. I've got segment PQ, which is a little segment, a smaller segment QR that's a little bit bigger than PQ, and also the total segment is PR, right? Right? So number 1, they tell us what the measures of 2 of the segments are. Y'all see that? They tell us 2 measures. Draw those on the picture. We're going to use pencil so we can erase it and do number 2. So if PQ is 9, so I'm going to go where PQ is. I'm going to write a 9 above it. And then they tells me that QR is 28. They want us to find the length of segment PR. Now, is PR one of the smaller segments, or is it the whole thing? The whole thing. So how do I find that length? I add the 2 smaller segments. So little plus little equals big. So 9 plus 28 equals what? 37. So 37, I don't know what the units are. Units equals the length of PR. Okay? Got it? Little plus little equals big. So if they tell you the measure, just write it in there and then do it. Okay, so I'm going to erase this. We'll do number 2. 2 tells me the length of QR is 17, so I'm going to label that one. And this time they're telling me the length of PR. Well, what segment is PR? The whole thing is 21 units. So this time they want me to find the length of PQ. PQ is the little tiny segment, right? Right? So if I know the whole thing and I know one of the smaller segments, how do I get the other small segment? Yes. You subtract. So if they give you the whole one, you subtract the smaller side they give you to get the other smaller side. Does that make sense? So this is going to be 21 minus 17, which is what? 4 equals the length of PQ. Does that make sense? So it just depends on what they give you. So that's why it's important when they tell you a measure, you label it on your picture. Okay? Because if I'm just looking at these letters and I don't use this picture at all, that's going to look like gibberish, right? Like, what the heck are they talking about? So always, 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 if they don't label something for you in geometry, you go back and label the picture. Okay? All right, number 3. Now we're going to actually do some little bit more complicated things. So number 3, it tells if EG, the length of EG equals 71. Now what is the length of EG? What is EG? The whole thing, right? Find the value of X. So we're finding X, so I don't know exactly the length of the two smaller segments, right? I don't know this length and I don't know this length. But I know together they equal what? 71. So how do you think I can make an equation to solve for X for so that I can do the segment addition postulate? Little plus little equals big, right? So that's what you do is you just set up the little segment, which is 8x minus 17, plus the other little segment, 5x minus 3, equals the length of the longest segment, which is 71. Y'all see that? Little plus little equals big. And you just create your own equation from that. Does that make sense? Now we go back to junior high and we solve this equation. Okay? So that's something that we're going to get used to in geometry. We're going to see it often. You're going to use some kind of geometry concept to help you create an equation based on the information given, and you're going to solve it. Okay? So remember, we combine like terms with our x's. What's 8x plus 5x? 13x. And then negative 17 minus 3 is what? Negative 20 equals 71. Then what? Add 20 to both sides. So 13x equals 91. Divide by 13. And x equals what? 7. Now, it asked me to find the value of x. What if they wanted me to find the length of FG? Could I? How would I do that? Yeah, plug 7 in right here. 5 times 7 is 35, minus 3 is 32. Right? And I can do the same thing with EF, right? Right? Okay? So sometimes it'll ask you to find x and then just stop. And then sometimes it'll ask you to go back and find the length of one of the segments. So you just plug in what you got for x into that expression. Does that make sense? Okay. Number 4. It says that TV, length of TV equals 14x minus 8. Now, what is TV? It's the whole segment, isn't it? Okay? It's the long segment, the big one. So, it wants me to find the length of TU. Well, TU has an x in it, right? So before I can find the length of TU, I got to find out what x is, right? So that means I have to make an equation. Y'all with me? Okay, so use the segment addition postulate. What does the segment addition postulate say? Basically, little plus little equals big. So what do I have for my two little segments? And then plus 5 equals, what's the length of the longest segment? All right, any questions about how we made our equation? Okay, so now we're going to solve that for x. Well, I got like terms right there, don't I? What's 2 plus 5? So 9x plus 7 equals 14x minus 8. I'm going to subtract 9x. So 7 equals 5x minus 8. And then I add my 8. 15 equals 5x. Divide by 5 and x equals what? I'm out of room. Do I stop when I get x here? No, they want me to find the length of TU. So how do I find the length of TU? Yes. So I'm going to say 9 times 3 plus 2. 9 times 3 is, plus 2 is 29 units is my final answer. Okay, so always answer the question. Don't just stop when you solve for x unless it's all it said to do. So any questions about that? Let me see. Why don't you guys try number 5 and number 6 on your own? Y'all try number 5 and number 6 on your own, please. And 6, y'all. Little. If you're finished, go ahead and check them with somebody. If not, finish it up. If I got something different, discuss it. I know some of y'all are rusty on solving equations. It's been a minute. All right, y'all look up here. Tell me how to set up number 5. Little plus little equals big. So 27 plus 3x minus 1 equals what? What's the length of the big segment? 5x plus 2. Now, my end goal is find the length of JL, which is the whole thing, right? But first, I have to find x, right? Okay, so I'm going to solve the equation. Over here, I have like terms 27 minus 1, correct? So I'll have a 26 plus 3x, or 3x plus 26 equals 5x plus 2. Get my x's together. 26 equals 2x plus 2. Subtract 2. I'm getting 24 equals 2x. Divide by 2, I'm getting 12 equals x. Did y'all get that? And then I got to finish it by finding JL. So JL is going to be 5 times 12 plus 2. 5 times 12 is 60 plus 2 is 62. Raise your hand if you got 62 for your final answer on number 5. Any questions about how I got that? Okay, so some of us just need to knock the cobwebs off on solving an equation, right? Because that's the most basic math thing we're going to need for geometry, solving equations. That's why you get preached at it from like 6th grade up. All right, number 6. Y'all tell me how I set up the equation for number 6. X plus 3 plus equals little plus little equals big, right? Now, this one just wants me to find x, doesn't it? So after it finds x, I'm done. So I got like terms on the left. What's x plus 8x? 9x. What's 3 minus 9? Equals 7x plus 4. And I'm going to get my x's together. And that gives me 2x minus 6 equals 4. I add 6. I get 2x equals 10. Divide by 2 and x equals 5. Raise your hand if you got x equals 5. Any questions? Y'all see me skipping steps? Y'all see me skipping some steps? Did I do that ever in Algebra 1? No. But what class is it? Well, yeah, I didn't show that I added 6 over here, and I didn't show dividing by 2 right there. Right? I just didn't show, but I got it right, right? If you can do this and get it right, and it saves you time, I'm okay with you skipping like little baby elementary solving equation steps. Got it? Y'all are honors geometry students. We're a little bit more mature now, aren't we? Now, if you cannot get it right, raise your hand if you got 5. Okay. If you can't get it right, you better not be skipping anything. Okay? Okay? Got it? Okay. Any questions? All right. Flip to number 7. Top of the back page. First of all, we got to fill in all these blanks, right? Y'all see that? Well, it just makes sense. X is the first thing we got to find, right? And then it just wants us to find the length of those 3 different segments, all 3 segments. Okay? So that means after we get X, we just plug it in for all 3. Notice they did not label the picture for us, did they? Did they label? No. So that's the first thing we're going to do is label. So first of all, SK, which is the left-hand segment, is 13x minus 5. And then KY is 2x plus 9. And the whole thing is 36 minus x, right? So that just helps me know how to set up my little plus little equals big. Now you really didn't have to, you really didn't have to label the whole thing if you could just copy it from there. But for sure, make sure you know which one's the little segments. All right, so little plus little equals big. How do we solve or set up our equation? Minus 5, okay, equals, very good. So like terms, my x's get me 15x. My constants get me a positive 4. And then I'm copying the other side. X to both sides. 15x plus 1x is 16x plus 4 equals 26. And then what do? Subtract 4 and I get 16x equals 32. And then I do what? 2. There's one of my blanks. Y'all with me on that? Everybody okay on that? Now how am I going to find the length of those segments? Plot 2 in for all your x's. So for SK, I'm going to say 13 times 2 minus 5. Well, 13 times 2 is 26 minus 5 is 21 units. Okay, and then KY is 2 times 2 plus 9. Y'all see what I'm doing there? 2 times 2 is, plus 9 is 13. And then the last one, SY, 36 minus 2 is 34. How could I check my answer? Yeah, the two shorter ones should equal 34. Do they if I add 21 and 13? Yes. So any questions about that? So that problem seems like it took a long time, but it's really not any more difficult. You just had to find all your segments. Does that make sense? Any questions on that? All right, let's talk about a midpoint. All right, the midpoint of a segment is a point that divides the segment into two congruent segments. So those three words are two congruent segments. So a midpoint is exactly the way it sounds. It's the point in the very middle of a segment. Okay? It sounds exactly like what it is. The midpoint is the point in the middle of a segment. Okay? And it divides it equally. Okay? So B right here is the midpoint of A and C. So AB and BC have the same length. Okay? And notice that they drew these little tick marks right here. If you see tick marks on a segment, that means that those two pieces are equal measures. So anytime you see little tick marks in segments, that means segment AB is congruent to BC. Any things that have the same amount of tick marks are congruent to each other. Okay? So that's a little clue they show us in pictures. Little tick marks mean they're congruent to each other. Okay, the middle bullet. A line, ray, or segment that intersects a segment at its midpoint is said to bisect. That's an important geometry word we're going to use all semester. Bisect the segment, and it's called the segment bisector. Segment bisector. Combined words. Segment bisector. So you see this line L right here that goes through that segment? It is called a segment bisector because it goes through the midpoint and divides that segment into two congruent parts. So a bisector, or the word bisect, means it cuts it exactly in half. Okay? Makes two equal pieces. So bisect means you cut it exactly in the middle to make two congruent pieces. Okay? That's what the word bisect. In geometry, that's what it's going to mean for everything. Whether we're talking about a circle, a triangle, a ray, anything that is a bisector goes exactly through the middle and makes two congruent pieces. All right? All right. In the diagram to the left, what is the midpoint? B is the midpoint of segment AC, and line L is the segment bisector. I already talked about that. Of segment AC. Because it goes through the midpoint, so that means it divides it in half. So, if we know that a point is a midpoint, then that tells me these two little segments are equal to each other. Okay? So down to the next example, number 8, it tells me Q is the midpoint of segment PR. Find the value of X. So it's telling me that Q is the midpoint. It's the point exactly in the middle. What do I know about these two segments? They're the same length, right? So how do you think I can solve for X? Exactly. I can set them equal to each other. If I know a point is the midpoint, then I can put my two segments equal to each other. Notice I can't use segment addition postulate because they didn't tell me the length of the entire segment, did they? They did not tell me the length of PR, but I don't need the length of PR because I know that Q is a midpoint. So that means whatever that length is, these two segments are going to be the same length. Does that make sense? So I can set them equal to each other and solve for x. So I'm going to subtract my 4x. What's 7x minus 4x? 3x minus 16 equals 2. I add 16. 3x equals 18. Divide by 3 and x equals 6. Now, if it told me inches or centimeters or whatever, you need to make sure you put that unit with your solution. But they didn't. Now, could I find the length of PR? Yeah, could I find the length of PQ? Yeah, and after I find PQ, QR better be the same thing, right? Okay, could I find the length of the whole thing, PR? How? Add them together, or you can do one and multiply it by 2. Yep. Let's just do it. What would be the length of PQ? I believe it'd be 26. Right? So the length of the whole thing is what? 52. Very good. So both of these would be 26. 26, and the whole thing would be 52. All right. Y'all are so smart. Y'all are so smart. Let's do number 9. Let's do number 9. So it told me H is the midpoint of segment GI. Find GH. So before I can find an individual segment, what do I need to find first? I got to solve for X. So since I know that H is a midpoint, how can I set it up to solve for X? Set them equal to each other. 5x plus 2 equals 9x minus 10. And I'm going to subtract 5x because I like to have positive x's. And then I add 10, I get 12 equals 4x. Are you getting x equals 3? Okay. And then I want to find which one? GH. So the length of GH is going to be 5 times 3 plus 2, which is going to be what? 17. Multiply and then add. What's the length of HI? What's the length of GI? 34. All right. Let's skip down to number 11. Number 10 is the same thing, right? No sense in doing every example on the paper, right? Right? Is that okay with y'all? Okay. Skip down to number 11, please. All right. So it says that G is the midpoint of FH. But then it goes on, and these both have X's in them. Do y'all see that? And then it says FH's length has a Y in it. Find Y. Okay, game plan. How can I do this? Very good. See, in geometry, it's always good to come up with a game plan, right? Start with what you know. I know this is a midpoint, so I know these two can be set equal to each other, right? And after that, I'll get X, but I need to find Y. And Y is in here with the length of the whole segment. So after I find X, I can plug it in and get the length of that whole segment and set that expression equal to that number. Does that make sense? Okay, so that's my game plan. So first I want to set 4x plus 3 equal to 7x minus 12. So I'm getting 3 equals 3x minus 12. 15 equals 3x. Divide by 3, and what do I get? Everybody getting that? Do I need to show more steps? All good? All right, so 5 is x. So I can find FG, can I? Start there. 4 times 5 plus 3 is going to be 23, right? So this is going to be 23, and since that was a midpoint, this is 23. So you don't even have to plug it in twice. You know if one side's one, if it's a midpoint, then the other one, right? So the whole thing together, FH is what? It's 46 units, right? And to get Y, I can say 6Y minus 2 equals 46. Y'all see how I'm doing that? Okay. So add 2. 6y equals 48. Divide by 6 and y equals 8 units. Okay? So go with what you know and then form your little game plan from there. All right. So all those had to do basically with the segment addition postulate. Flip over to the second page, which would be really the third side of page. And we're going to talk about the distance formula. Okay? The distance formula is what we're going to use to find the length of a segment if it's given on a graph or by ordered pairs. Okay? So if there's ever somebody that wants to, if you want to find the length of a segment on a graph, you want to use the distance formula. Okay? Or if they give you coordinates, because that's talking about a graph, right? So the distance formula. Raise your hand if you remember doing this in Algebra 1. You might not remember the formula, but you remember me or your Algebra 1 teacher talking about it. D equals big long radical x2 parentheses x2 minus x1 parentheses squared plus parentheses y2 minus y1 close parentheses squared. Okay? And your x1 and your x2 and your y2 and y1 come from the two ordered pairs. All right. Dun, dun, dun. So you need to memorize that formula. I'm going to highlight it. It's important. You have a test when? Tuesday. Today is Wednesday. So less than a week away. You need to make sure you have that memorized, okay? x2 minus x1 parentheses squared plus y2 minus y1 parentheses squared. Then you take a square root. So it's just plugging in and doing arithmetic, y'all. That's all it is. So number one, they actually give us the graph, don't they? Right? They give us a graph of a segment. So we want to find the distance between 2 points of the graph. Well, the distance between these 2 points is also the length of the segment. Okay? The distance between 2 points is also the length of the segment. Okay? So how do you think I can use the distance formula on this graph? Yeah, you need the 2 points, don't you? So what is this point right here? What's that ordered pair? Okay. And what's the other coordinate? Y'all agree those are my 2 points? Okay. Well, I'm going to plug those into my formula. D equals big radical x2 minus x1 parentheses squared plus y2 minus y1 parentheses squared. All right, now I'm going to label my points. This is x, this is y, this is x, this is y. The first ones are the 1s, the second ones are the 2s. Right? Y'all remember that stuff? You also need those x1, y1s when you do slope formula. Remember that? Way back in the day. So D equals big radical, parentheses. What number is my x2 number? -2 minus what is y or x1? -5 parentheses squared plus what's y2? -3 minus what's y1? +3. All right. So now we simplify all these square root stuff. A minus and negative is a plus, right? So -2 plus 5 is +3. So 3 squared plus, what's -3 minus 3? Try again. -6 squared. And if I square anything, it's going to be positive, right? Right? What's 3 squared? 9 plus negative 6 squared is 36. And then what's 9 plus 36? Is how much? Now, we learned how to simplify radicals a long time ago. Y'all remember that stuff? But I'm going to let you approximate them today. So D is approximately, calculator. Y'all know how to take a square root in your calculator? Has it been a minute? Let me get a copy of my calculator and show you. Okay, there it is. Uh-oh. So I'm taking the square root of 45. You're going to hit seconds. I got to clear my screen. The second button, top left corner, is the one that's a different color. The square root button is diagonal from the 7. So you're going to hit second, square root, and then 45. Second, square root, 45. And that is approximately. Now, see how I put squiggles down here? We rounded. This is not equals. It's squiggles. We're approximating. It's approximately 6.7 units long. So the distance between those 2 points is approximately 6.7, and also the length of that segment is approximately 6.7 units. It means the same thing. Okay? So the distance between 2 points is also the length of that segment. Now, y'all, the distance formula is basically memorizing a formula, and then you're add, subtracting, and multiplying, and taking a square root. That's it. It's arithmetic. Y'all know what arithmetic is, right? Add, subtract, and multiply and divide numbers. That's it. Okay? It's what you were doing in math since kindergarten. No algebra to it. So number 2, they didn't give you a graph. Did they? No, they just gave you the ordered pairs. That's fine. That's simpler for us. We don't have to look and pick out those points. Okay? So we're going to plug it into the formula. D equals big radical, parentheses, x2 minus x1, parentheses, squared, plus y2 minus y1, parentheses, squared. So D equals square root. What number is x2? Minus x1. Negative 4, parentheses, squared. What's y2? Negative 11 minus, negative 1 minus squared. Did I plug everything in correctly? All right, so that's the same thing as 3 plus 4, which is 7 squared plus negative 2 squared. What's 7 squared? 49. Plus negative 2 squared is 4. So D is going to be the square root of 53, which is going to be approximately what in our calculator? Something's wrong with my calculator. Square root of 53. I'll get about 7.3-ish. And I'm okay if you round it to just one decimal place. Just make sure you put squiggles. Okay, because equals means exactly. Okay, we're rounded, so we're not exactly. All right, I want y'all to try the next one. Y'all can go ahead and check with somebody when you finish. Okay. So I've already wrote my formula. Y'all help me fill it in. What's x2? 11. Bless you. What is x1? If I go ahead and put my plus 7 there, would that be okay with y'all? It's just less crowded. If y'all do it that way, it's not going to hurt my feelings either. What is y2? Minus what? So I'm going to go ahead and change that to 3 plus 2, if that's okay with y'all as well. So that's going to be 18 squared plus 5 squared. Did y'all get that? What is 18 squared? 324. What's 5 squared? We're thankful for calculators. So I add those together and I get the square root of what number? 349. And you take the square root. Approximately what? I trust you. Raise your hand if you got D is approximately 18.7 units. Any questions? All right, one last thing I want to show you today, and that is midpoint formula. The midpoint formula is if they have it on a coordinate axis and you want to find the exact ordered pair for where the point in the middle of a segment is, you will use the midpoint formula. Okay? So the formula for a midpoint is parentheses. You're going to use the two endpoints they give you. And it's x1 plus x2 divided by 2. And y1 plus y2 over 2 in parentheses. Because the midpoint is a point, right? So that's why it's parentheses, comma, number, parentheses. Now, if you think about the midpoint, your x coordinate is going to be your x in the middle of your x's. The y coordinate is going to be the y in the middle of your two y's. So notice that you're adding your x's and dividing by 2 and adding your y's and dividing by 2, right? If I take two things and I add them together and divide by 2, I'm finding their what? Average. So it's basically, to think about it, if you forget this formula, it's the average of the x's and the average of the y's. Okay? So that's a simple way. If you forget the formula, you can still find a midpoint. You just add the two x's divided by 2, add the two y's divided by 2. Right? It's that simple. All right. So, number 4. Find the midpoint of segment GH, and G is this, and H is this. Okay, so those are my two endpoints. So to find the midpoint, I'm going to add my x's, parentheses 7 plus 9 divided by 2, and then add my two y's, negative 5 plus negative 1 divided by 2. Keep them in ordered pairs, put a comma in between. So do your numerators first. What's 7 plus 9? So that one's going to be 16 over 2. What's negative 5 plus negative 1? Negative 6 over 2. And then you simplify. What's 16 divided by 2? 8. What's negative 6 divided by 2? Negative 3. So the midpoint is the point 8, negative 3. Well, let's see if that makes sense. Is 8 in between 7 and 9 for the x's? Yeah. Is -3 in between -5 and -1? Yeah. Okay. So your answer should kind of make sense like that. Does that make sense? So midpoint formula is actually really, really easy. You just add the x's divided by 2, add the y's divided by 2. Y'all try number 5. Try it and see what you get. All right, check it with each other. Did y'all get -2, 0? Any questions? All right, I want y'all to do one more problem. Turn, just one more. We're skipping a lot. We're going all the way to the very, very end. The very last problem on your notes. Yes, this one. The very last problem on your notes. Y'all see that number 11? I gave you a picture. Okay? So, using the diagram to the left, if line N bisects segment QR, what does that mean, bisect? Cuts it exactly in half. It goes through the midpoint, right? Find the length of QP. So line N is a bisector. It cuts it exactly in half. So what does that tell me about this figure? That these two little segments are congruent to each other, correct? So how can I find X? Yeah, so it's important to know that word bisect. So before I can find the length of QR or QP or anything else, I have to get my X. So I can set those equal to each other because that word bisect right there is an important word. Okay? So solve for X, and I'm going to do it too and see if you can look up and see if you got what I got. Did I do it right? I keep unplugging my computer. It's going to go dead on me. I keep kicking. Did y'all get 12 for X? All right, so what does it want us to find? The length of QP. So QP is going to be 3 times 12 plus 5. What's 3 times 12? Plus 5 is 41. What's the length of PR? What's the length of QR? 82. Very good. All right, so you have your practice packet from yesterday. Get that out. Okay. Get out your practice packet, please. I'm looking for my eraser. Okay. you're going to finish the packet for practice, but it's not due until Friday. Okay? Now keep in mind tomorrow, we're going to learn about angles. So you'll have more practice coming on at you tomorrow, right? Right? So, I just know that today was kind of a long lesson. And I'm going to stop my video.